In this video, we're going to take a look at finishing off the airbag shape. Now I want to start by pointing out the fact that we spent a lot of time on our trim sketch for our last surface. It's important that we deal with the curvature in the sketch because that's going to create a good or a bad surface. To start off our new surface, we're going to start a sketch on the front face of our steering wheel plane. Go ahead and turn our sketch picture back on and take a look at what kind of curvature we need to create. The first thing I want to create is a 3-point arc. We're going to try to mimic this top edge of the lower surface of the airbag. So we're going to start by snapping to the center, drag it down roughly about where the curvature starts to change, and get it as close as possible. The next thing we want to do is select the top edge of our steering wheel base and control select the arc. We're going to make these concentric. Once we drag this into an appropriate position, we want to go ahead and fix the endpoint. As long as the right endpoint is close to the curvature of the picture, we can go ahead and fix that as well. So now we have a 3-point arc located roughly the same curvature as our sketch picture. And it's important to note that there's a lot of pixelation, so you're never going to be able to get an exact replica because the resolution of the picture just isn't there. So we want to make sure that we get it close and we base it on surrounding geometry, such as the curvature we use to create our steering wheel base. The next thing we want to look at is creating the bottom edge. Now we don't have any surrounding geometry to help add relations to this, so we want to start by creating a line. We're going to make it for construction. We're going to draw a horizontal snapping to the center. I want to make sure that this line is fixed and then start a new 3-point arc. I'm going to snap to the end of that line, drag it about where you think the curvature starts to change, then we'll go ahead and roughly place the curvature. Now with this line, we want to go ahead and add a tangent relation with that straight line, and then drag the end around to make sure that we're matching the curvature as best as possible. Then we can fix that endpoint as well. Let's move on and create some more geometry. Now if you remember when we created the steering wheel base, we used a straight line for this segment. It's going to best represent the geometry that we can see on the sketch picture. So I'm going to go ahead and I'm going to use a straight line for this inside segment. I'm going to make it as close as possible. Then we're going to apply a parallel relation to that outside edge. Again, we're never going to be able to exactly replicate based on the picture and pictures alone. The picture is going to have a certain amount of skew. We know based on some earlier videos where we mirrored the geometry to the other side that it doesn't match exactly. So the fact that this line doesn't exactly match the picture isn't a huge deal for us. We just want to make sure that we base everything as much as we can on the surrounding geometry we decided to create. So now that we have this line roughly in place, I'm going to fix its endpoints. Next, I want to take a look at adding a spline between these two. Now it's important to note when we're dealing with geometry such as this where we fixed relations, you can often get errors when you go to fully define your sketch. So let's start by drawing a start and endpoint spline by snapping to each of those, hitting escape to end the spline, and then let's add some relations here. One thing I want to note is when we're dealing with splines, we have the two handles on either side. If we apply a tangent relation between the 3-point arc and our spline, that's only going to drive the direction of the handle here. If we apply a curvature relation, grab this line, grab the spline, do equal curvature, it's going to apply both a direction and a weight of this handle. Depending on the surrounding geometry, it's important to understand the differences and know when to apply them. In this case, I applied an equal curvature relation, but this line is straight, which means it doesn't have a radius of curvature. So I'm going to go ahead and undo that. What I want to do is simply apply a tangent relation there. For the relation down with our 3-point arc, the arc has a constant radius of curvature. That means that we can give this a set number. For instance, if this was a 100mm radius, and that 100mm radius would carry into the spline. For that reason, I'm going to go ahead and leave both of these ends as tangent and make sure that my curvature combs look nice and smooth. I'm going to make sure that we didn't induce any sort of funky relation in the middle of this spline. I'm going to go ahead and leave that on. Next thing I want to do is create some geometry to start to fill in this section here. Now we could do this with 3 separate segments, similar to how we did this bottom section here, or we could try to do it with one spline. Let's go ahead and apply one spline and see what we can do to get the curvature right. Again, I'm going to do a start and an endpoint spline and apply some relations here. Again, we're going to do tangent relation here. and tangent relation up top. Now notice that the geometry obviously doesn't match very well. We can drag these handles around, but we're never going to get to fix that geometry because it's got a different set of curvature in the middle. So if we right click on this, we can insert a spline point, left click on the spline, and we can help drive some of this geometry by changing the handle in the center here. I'm going to drag the weights around. I'm going to move this point around. Now it's important to note that you don't want to add too much curvature here. We want to be careful that we're not inducing any sort of issues in the curvature combs. And you'll notice by adding that midpoint or that third point that we're actually adding a reasonable amount of curvature right here in the middle. So the reason I mention this is because any issues with your splines and your geometry in this sketch can show up later in the surfaces. So right now you can see that we have a changing curvature really close to where this handle is. We go from concave to convex. And by dragging these handles around, we can change that drastically. So what we want to do is pull this handle around and see if we can get kind of a reasonable association without inducing too many problems into the curvature here. So again, we can kind of move these handles around and play with the geometry. Now I think that looks pretty close, so I'm going to go ahead and OK that sketch. And I want to create a boundary surface between these two. Now you might be wondering why I'm not creating geometry between the endpoints of this. Well, I want to be careful not to over-define my surfaces. And the reason I say that is because you have a lot of tools at your disposal for creating references and geometry between these. So let's start by doing a boundary surface. Going from this edge, I'm going to right click, use my selection manager, grab this one edge, hit this button which will grab all the tangent entities, and hit OK. And you can see that we're creating a boundary surface between these. Now I want to add some relations here. With this open group, I'm going to add a tangent to face relation, and I want to give this a 0.5 weight. With my sketch, I'm going to add a normal to profile, but change the degree. So I'm going to give this a 10 degree, make sure that it's going the right direction, and I'm going to give this handle a 1.5. So we get a preview on the screen, and you'll notice that we have some interesting curvature in our zebra stripes going on in this area. If we look at the curvature getting close to our surface, you can see the combs go out quite a bit. If we look closer to the bottom where our steering wheel base is, it's quite a smaller degree of the radius of curvature. Now this is going to show up for us in our surfaces. So you need to be able to drive these or play with these. In general, you're not going to create a surface this big with one shot. You're going to want to define certain areas to help drive your shape. But in this case, we're going to go ahead and use one surface and play with it and see if we can get over those shortcomings of creating a single surface. I think this is a good place to end this video. So let's take a small break and we'll come back and take a look at some of the issues we've created with this surface.